right. Hey, oh, I think it's recording now. All right. Hey, everybody. It's me, Miss Moncrief, helping you out here with a new lesson. We are looking at lesson 7.7, which is now writing exponential functions. We've already looked at that before, so some of this will just be review, but sorry, I'm trying to write my name still. Some of this will just be review, but you are going to learn something new today. All right. So let's take a quick let's take a second to remember one quick thing, and that's the difference between linear functions and exponential functions. So first off, linear functions. They increase or decrease by that constant rate of change or the slope. You find that by subtracting backwards and finding a common or first difference. Multiplication is repeated addition, and the opposite of multiplication is division. All right, and then let's also remember what exponential functions are. Hopefully you really remember what exponential functions are, since that's what we've been learning. And these decrease or increase or decrease by a growth or decay rate, which varies, and that is our multiplier. You find that by dividing backwards, and then they use powers instead of multiplication. So powers are repeated multiplication, and the opposite of a power is a root. That's going to be really important to remember here. That opposite of a power is a root. All right, so let's remember a couple of things. Recall, since x values are not consecutive for linear functions, we divide by 2 to get the slope. What do we need to do to find the multiplier for an exponential function? All right. Sorry, that's the bell. 1 second.
Third lunch, blue, grab and go, may head to the cafeteria. Third lunch, blue, grab and go.
All right, so let's look at this first table. Let's see if we can make an equation out of it. All right, so let's start by seeing if it's linear first. To tell if it's linear, we're going to subtract on the y side and see if we get the same values, much like we did with arithmetic equations, or arithmetic sequences, my bad. But let's check, see if it's linear. So if we subtract between these three numbers and get the same number each time, it's going to be linear. So what is 18 minus 12? You guessed it, that is 6. And now what is 12 minus 6? All right, that's also going to be 6. So since we subtracted and got the same number, we know that this is definitely going to be linear. And remember, if we're looking for linear, we're looking for the slope. So, and remember, the slope was going to be the change in y, so delta y over the change in x. Do we know the change in x yet? No, let's find it. So it's 6 minus 4. Let me hide this menu. 2. What's 4 minus 2? 2. And what is 2 minus 0? Again, that is 2. So in order to find the slope now, we need to do delta y over delta x, which would be not 0. I don't know what that was about. Which would be 6 over 2, which is just 3. So overall, we know that my slope is 3. What else do you need to know? Well, what's the equation? How do we write linear equations? What's that form? We write them in slope-intercept form, which is y is equal to mx plus b. We already know what my m is, which is 3. So now we got to find my b, which is my y-intercept. So let's do that by subtracting 6 by 6 in order to work backwards. So what is 6 minus 6? And that would be 0. So our equation for that is going to be y is equal to 3x. So we know that one's linear. All right, so now let's look at the next table. We need to figure out first if it's linear or exponential. So let's see if we subtract and get the same numbers like we did here. So what is 729 minus 81? All right, that's 648. Cool. And now what is 81 minus 9? Oops, accidentally put two minuses, minus 9. That's 72. Those aren't the same, so is this going to be linear? No, this is actually going to be exponential, so we're going to do what instead of subtract? We're going to divide. So what is 729? 729 divided by 81. Well, that's 9. Okay, we can do that. That 9 makes sense. And now what is 81 divided by 9? All right, and that's the same. So we know for a fact that this is definitely going to be an exponential function. This is definitely going to be exponential. Ugh. If I can write it out, goodness, exponential. So we know for a fact that this one's going to be exponential. Well, remember, if you remember back to 7.3 maybe? Yeah, 7.3, we had to check the difference in the x values because this is to see if they were 1. So let's check the difference in the x values here. So what's 6 minus 4? Well, that's 2. Okay. What's 4 minus 2? Well, that's also 2. And what's 2 minus 0? That's 2. Okay. So last time we looked at exponential functions, the difference for every one of them was 1. So it was easy. The multiplier was just what we got when we divided. This time, since the difference in x's is not 1, since these numbers are not consecutive, that means we have to do something else. So what we need to do to find the multiplier for an exponential function when the x values are not consecutive, we will take that root. We will take that root of the number. We will take the root. So remember a long time ago we talked about taking the square root, which was just the opposite of squaring. So if we have 2 here, we are going to take the square root. So what is the square root of 9? Well, that would be 3. So we know that our multiplier is going to be 3, which is great. So now we got to find, so now that we have my multiplier or my b for when we're writing this, now we got to find my a, my y-intercept. How are we going to do that? Well, since this is still in the pattern of, since 0 to 2 follows the same pattern that my other differences did, we can just divide going up again. So what is 9 divided by 9? That is 1, so my y-intercept is 1. So that means we have y is equal to 1 times 3 to the x. Or what we prefer you to just say is y is equal to 3 to the x. All right. So that's like a quick view of what we're going to be doing. I am going to do work a few more examples with you. So let's go ahead and look at the next one. All right. So let's review writing exponential equations. So we were given y is equal to a times b to the x. What is our a again? That is our y-intercept. And what is our b? That is our multiplier. Ugh. I wish I wrote faster, but if I write any faster, this handwriting is gonna be so much worse. So let's look at this. Write an exponential equation given 2 consecutive points. So that means it's one after the other. Let's look at what our points are. We have 2 and 75 and 3 and 375. Now if you remember back to 7.3, when we first learned about writing, we always wanted to have 0 on the table. So we're going to go ahead and put that down. And then let's just go consecutively until we get to 3. So 1, 2, 3. Now again, what was our x value at 2? Or what was our y value? Now do we have 0? No. Do we have 1? No, but we have 2. And what is it? 75. And we have 3. What is that? 375. So from just these 2 points, oh, sorry about that. From just these 2 points, can we find the multiplier? Yes, let's do it. So let's start by dividing our y's. What's 375 divided by 75? 375 divided by 75. Well, I got us 5. So right now we kind of assume that our multiplier is 5. But let's go ahead and check the difference just in case we have to do that root again. So what is 3 minus 2? Well, that's 1, so we don't have to take the root. So what is my multiplier? 5. My multiplier is 5. Alright, so now, though, we have to fill in the rest of this until we get to 0. So what do we do with our multiplier to work backwards? We divide by our multiplier. So what's 75 divided by 5? Well, that is 15. Are we at 0 yet? No, so we got to divide by 5 one more time. And that'll get us 3. So what's my y-intercept here? 0, 3. And now I'm going to take this moment, because I just graded quizzes, make sure anytime we ask for the y-intercept, you are putting 0, 3. I'm sure there's more than just my students, but if you are not writing 0, 3 or 0, whatever that number is for your y-intercept, you're getting that question wrong. Make sure when it says y-intercept, you put it as an ordered pair. Alright, anyways, now let's keep going. So now that we have our multiplier and our y-intercept, let's go ahead and put it into our equation. Our y is equal to a times b to the x. Alright, what was my a? That was my y-intercept, so 3 is my a. And what was my b? B is my multiplier, so that is 5. So we would just put those into those places. So we have y is equal to my y-intercept, 3, my a, times 5 to the x. And that's it. You guys are pretty good at those. So let's go ahead and move on to b. B says write an exponential equation given the y-intercept and a non-consecutive point. So this is where it gets into what we're really learning today, the non-consecutive point. So remember, anytime we're writing an exponential equation from a graph, we need to make a table. So let's do it. So I have x, y, and we always want a 0 on there. So we got 0, 7, we know that one. So we got 0 and 7, and what's my other point? Oh, that's so gross to read. Let me fix that for you guys. So x and y. So we know we have 0, 7, and we have 3 and 56. So again, let's go ahead and do the first step we know to do always when we are finding the multiplier. Let's go ahead and divide the y's. What is 56 divided by 7? So we have 56 divided by 7, and what does that get us? 8. So we know that that part is 8, but is my multiplier 8? I don't know. Let's check something. We got to make sure the x values are consecutive, so we subtract to make sure they're 1. What is 3 minus 0, though? Oh my gosh, that is 3. That's not 1. So that means we have to take the cubed root of 8. We have to take the cubed root of 8. So that's going to look like, what is the cubed root of 8? So that just means what number can we multiply by itself 3 times to get 8? Some of you might I just don't like where that's placed. Some of you might already know what it is, but if you need to, I can show you in the calculator. So go to math, go down to 4, and that's how you get the cubed root. So the cubed root of 8, and let's see what it is. Well, that is 2. So guess what my multiplier is now? My multiplier is now 2. So my multiplier is 2. Do I have my y-intercept? Yes, I do. It's right here. It's at 0, 7. So we have Remember, ordered pair, 0, 7. All right, and now we can plug that in to our y is equal to a times b to the x, and that would be y is equal to 7 times 2 to the x. So the new part that we were really learning today is that when this difference is not 1, we will take that number root of what we divided. Okay? When this difference is not 1, we will take that number root of what we got when we divided. One more announcement.
Third lunch, orange dine-in may head to the cafeteria. Third lunch, orange dine-in.
All right, and let's look at a couple more examples. So example 1 says, write an equation given 2 non-consecutive points. So let's look at the first one, example 1a. Let me get back to the pen and hide this. So we were given this exponential functions with the point 1, 6, and 324. We even have a lovely table filled in. So let's talk about the steps we're going to take to get there. The first step is going to be to divide the y's. So what is 6 divided by 24? Well, that would be 4. 6 divided by 24 is 4. So even over here, it's starting to list the steps. So I'm just going to write it out. First, divide. Oh, no. Divide y's. Oops. Divide y's. It's ugly, I'm sorry. All right. And then the second step I would say would be subtract x's. Subtract x's. So what's 3 minus 1? Well, that's 2. So we subtract the x's. And so that 1 and 3 is 2. So b square root of 2. Okay, so subtract x's, and we will now take the square root of 4. So we will now take the square root of 4. So if you didn't know, and this might be something that confused you when we did the first one. So if you didn't know, anytime you're taking the square root, there's this invisible 2 right here. That is the squared root. You saw me write 3 down here. That's where the root comes in. So, but there's an invisible 2 right here anytime you take the square root. So that is why I don't really write a 2 there. So we will now take the square root of 4, which is what? 2. The square root of 4 is 2, so that is now our multiplier. That is now our multiplier. So now we found our multiplier, we need to find the y-intercept, which we could just take our multiplier and divide backwards from where we were at 1. So divide 6 by 2, which was our multiplier, and we got 3. So we know that this is 3. And that would leave us with y is equal to 3 times 2 to the x. All right, and now let's look at one more problem, looking at B. So we were given the points 2 and 16 and 6 and 256. So the first thing we need to do is find the multiplier. And remember, the first step for that was divide y's. Let's divide y's. So what's 256 divided by 16? Well, that would be 16. Second is going to be subtract x's. So what is 6 minus 2? Because those are the two x's that were given with the points. 6 minus 2, oop, that was 5. That's 4. Okay, you guys know what 6 minus 2 is, and that's going to be 4. And then the third part of finding the multiplier is going to be take the root of this. Take the root of. Take the root. Take the root. So in this case, we're going to take the fourth. Oops, I didn't mean to do that. We're going to take the fourth root of 16. We are going to take the fourth root of 16 because we want what we got when we subtracted in the root part, and then we want 16 in there. So we are looking for what number can we multiply 4 times to get a 16. Well, if you don't want to think about that too long, we can always go to the calculator to help us out. Now everyone click math. Go down to option number 5 and click enter. You should have a blinking box right here. So here in the root, we're going to put what we got when we subtracted the x's, and that was 4. And then we are going to put 16 on the inside. And then we're just going to click enter and see what we get. We got 2. So my multiplier is 2. Now, since we found our multiplier, we need to find the y-intercept by subtracting from the 1, by subtracting 1 from 2 in order to figure out how, by substituting 1.16 to a times. So one way we can do it in order to find the y-intercept is by plugging in one of the points into our equation. So we know that we have, into our equation that we have so far. So we know that this is y is equal to a times b to the x. Oops, forgot my parentheses. And we know that b is, for a fact, b is definitely 2. So we have y is equal to a times 2 to the x. But I don't have a yet. But I have an x and a y somewhere. I have one right here. So what we can do is we can plug in that x and y and see what we get for a. So what is y? 16. So y is equal to, I don't have a yet, a times 2 to the power of, and what is x? 2. So we can do part of this. So what's 2 squared? Well, 2 squared is 4, so we have 16 is equal to a times 4. And then what do I need to do to get a by itself? Well, I need to divide by 4. And then what is 16 divided by 4? Well, that is 4. So a is equal to 4. And we can plug in a for 4. So we got y is 4 for a. So we have y is equal to 4 times 2 to the x. So you can either do that by plugging in your multiplier and an x and a y that it was given, or you can fill out the rest of your table. So we started at 216 is the lowest point it gave us, and we can just work backwards with our multiplier. So what's 16 divided by 2? Well, that's 8, so I got 1 and 8. And then what's 8 divided by 2? Well, that's 4, so I got 0 and 4, and it gave me our y-intercept. Those are 2 options of how to do it. Do whichever way you feel comfortable. And that is all for lesson 7.7. Now remember, A, always make a table when you have a graph. B, use when your x values aren't consecutive, so that means you get a number other than 1 when you subtract, you got to take the root. You got to take the root. If you have any questions, I'm sure your teacher would love to answer them for you. Just message them any day. Have a lovely, lovely, lovely afternoon, morning, day, whatever time of day you're watching it. All right, bye.